Hi guys, welcome back after the break. With me is Jakub Mazurek from Golem, and he's gonna give you an introduction to Golem's SDK and give you some more details about their bounties. So without further ado, enjoy the workshop. Kuba, the stage is yours.
All right. Thanks, Antek, for the introduction. So yeah, hello everyone. Welcome to the session and to the hackathon as such. What this workshop is going to be about, it's going to be split into like two parts. So the first one, the first kind of half of it, is going to be more of a presentation from myself, and the second half is going to be a bit more hands-on, where I'm going to show you parts of our documentation and how you can set up your Golem node and your testing environment. But it's not going to be like a live coding session. If that's what you expected, then maybe disappointed, but I hope not. In any case, let me switch over to my presentation and kind of tell you about my goals for this session. So what I tried to think of was what sort of information I would find useful if I were to participate in this kind of hackathon. And with all this information kind of scattered around different places, I've decided to try and gather as much knowledge as I can fit into this time slot. So I'm going to start with an overview of the Golem project as such, for those of you who may be unfamiliar with it, or maybe you just don't remember some stuff that's been happening recently, because there's been a lot of activity around the project. And then I'm going to kind of walk you through the Golem APIs and the architecture of the project, or at least from a very high level point of view. And finally, in this more practical part, I'll show you how to set up, how to test your application, both on the network itself, but also locally, and maybe give you some tips on how you can debug it and that sort of thing. So yeah, my hope is that you can get some value out of this, regardless of your familiarity with Golem and with these blockchain-related topics in general. Right. Before we start, there's two more things. One is you can ask questions at any point during the session. I'll do my best to answer them as we go. You can use this feature of Airmeet for this. So on the right, there should be like a questions box. There's chat as well. And finally, you can raise your hands, and I believe I can give you the mic if you prefer to speak rather than write something. And yeah, one more thing, I've prepared a collection of links that I'll be referring to during this presentation. I've put them up on GitHub, so let me just paste it into the chat right here. Cool. So that should work. So yeah, you can take a look at it during this session, and I'll let you know whenever there's something that you can take out from it. Cool. So yeah, let's get going then. So the first thing is the introduction to Golem itself. Right. So let's start off with the most basic question. So what is Golem? And depending on whom you're going to ask, the answer may be somewhat different. It may vary. So here's one take on it. Golem is a decentralized marketplace for digital resources. This includes computing power as kind of the prime example. So as a marketplace, it's formed by all the nodes that are connected to it. And in the case of the Golem network, these nodes are the user's machines. So anyone can join and participate, basically. And right, so what does it mean that it's a marketplace? Well, typically in this setup, in a marketplace, there will be supply, demand, and resources being exchanged. So in the case of the Golem network, the supply part are the providers. So here on the right on this graphic, and the demand part are the requesters on the left. So the providers are basically sharing some resource. So for example, part of the computing power in exchange for some value. In our case, these are going to be the GLM tokens. And the requesters are the nodes which come to the network and want some computation done, basically. So they have a task and they want to get it computed, and they offer you some GLM for it, basically. But there's one more side to this whole equation, which is the developer. So that's you, basically, in this case. So what would make you kind of interested in developing applications for Golem? So one reason for this is that everything that we do is completely open sourced, and it's also licensed using a permissive license. So you can easily audit and learn what's happening kind of behind the scenes. There are no parts that are hidden from you, basically. And also, since the whole network is decentralized and based on peer-to-peer connections, it's very much resistant to censorship, but also to some central failures. There is no central agent, central point of failure in this case. And yeah, the third point on the slide are the payments, which are currently taking advantage of all the new stuff that Ethereum Layer 2 brings us. And more specifically, this is like ZK Sync. So we have very low transaction fees, and we don't need to have different tokens for the fees and so on. But I'll cover this in a second. The last thing that would kind of be of interest to you as a developer is that we've put a lot of effort into making Golem easier to integrate with. But yeah, all of these things have been introduced with what we call the new Golem. So let me tell you a little about what it is right now. So the new Golem as a project has been around for quite some time already. With the first idea was presented back in 2014, I believe, and the ICO was in 2016. And since then, the project was kind of successfully running on mainnet with the previous implementation. But as time went by, certain limitations of that implementation were kind of becoming apparent. And as Golem Factory as a company decided to address these issues by creating this new sort of implementation, which is dubbed Yagna, which comes from, I don't know, you pick it. It's yet another Golem network something. So Yagna was unveiled sort of last year, and along with it came a lot of different various changes, which I'm going to tell you about in a second. So Alpha 1, we released it last year around August, and we've been moving pretty fast with this. So we are currently live on mainnet with this new implementation, and it's already in beta stage, in beta phase. You can find a link to the repo in this kind of link collection that I gave you. Okay, so now onto the actual features of this new implementation. So the first thing that you need to keep in mind is that basically we've changed the whole underlying network protocol and the architecture of the application. So this is by far the biggest change, and it was based on our experiences from the previous iteration and hundreds of hours of conceptual work that went into it. And as a result, we managed to create a sort of a comprehensive REST API for this new Golem. And this API is a very central point to everything you do as developers, because to control a node, you're going to use it in some way. In the previous iteration, the previous Golem version, we relied on RPC calls, and like when you compare these two, the REST API based on HTTP is much more flexible and structured, and it can also take advantage of a lot of existing tooling. And we're also going to see some of these examples in a moment. And yeah, finally, there is also the token, the Ethereum token itself. So we've migrated to a token that's compliant with the ERC20 standard, and this allowed us to take advantage of a lot of new things, basically. So previously, you needed to have both Ethereum and GNT. That's what the Golem token was called back then. And yeah, you needed Ethereum to cover the fees and GNT to pay for your tasks. It was also slower because everything was done on chain and so on. So a lot of improvements on the payments front as well. And besides these points, as you can see here, there's also the fact that we've rewritten the whole Golem daemon using Rust, which resulted in improved performance and the actual binaries being smaller in size. And finally, as I mentioned, we kind of put more emphasis on simplifying the setup process for developers, for people who want to create something with Golem. Right. So yeah. So I mentioned the REST API. I think that it's kind of worth focusing on for a bit. So the next part of this presentation is actually going to take you through the new Golem REST API. Right. So this API is split into like three main parts, and these parts represents the different stages of interaction, which I'll try to like briefly explain to you right now. So first of all, there's like the market API, and the market API is focused on all the kind of marketplace mechanism. So it handles objects such as demands and offers, and basically allows you to publish both of these to the marketplace. You can observe kind of what's going on, and yeah, I think I have some. Yeah, right. There you go. So this kind of demonstrates these objects from a higher level perspective. So the request is going to publish a demand, which I'm going to show you in more detail in a bit. And on the other side, the provider is going to publish an offer, like saying basically what they're capable of, and the requester is kind of saying what they are looking for. So yeah, and the demand a demand looks something like this. There'll always be two collections, one called properties and the other one called constraints. So the properties section is describing the task that the requester is coming with. So there will be some expiration time. There will be the package. So for example, the VM image that should be used for this task, and so on. So this kind of describes what the requester wants to get computed. And the constraints refer to what the requester is kind of expecting from its providers. So if you know that your task requires some amount of memory for each chunk, then you can specify this here. And on the other hand, this offer object is going to be very similar, but this time the properties relate to the provider. So we can find the same keys that we've seen in the constraints just a moment ago, but this time they are the properties. And this is kind of the whole marketplace matching mechanism. So for a match to happen, the properties of one side must be matching the constraints of the other side. And when this happens, so when the requester is sort of scanning the marketplace, when the requester notices that there are some offers which are matching whatever he or she wants to get, basically, we move on to the negotiation phase. And negotiation happens directly between the requester and provider. So there is a direct connection established, and they can exchange a number of messages to sort of establish the terms under which the provider is going to work, essentially. And if this negotiation is successful, so if we reach some consensus, then the requester issues an object called an agreement to the provider. And if the provider accepts this agreement, then this is where the market interaction ends, where it's finished, and we move on to the next kind of phase. And the next phase is the activity. So having an agreement struck, we can now proceed to actually performing some work. So in the case of exchanging computing power, the requester is going to be running some application that you might create in this case, and this application is going to be sending some commands to the containers that the providers run. Right, so we have some task. We kind of know how to split it into multiple chunks so that we can execute it in parallel on multiple providers. And for each of those chunks, we have some instructions, such as transferring a file, running a script, or getting a file back to the requester. And this is all of these things are covered by the activity API. And we're going to see this in a bit more detail later on when I show you one of our example applications. So you can get a slightly better idea of what this API looks like. Right. So, and finally, we have the third kind of part of this whole equation, which is the payments API. And in the most usual case, where we go from from market to activity, and once an activity is finished, and the provider has computed something for you, it's time to transfer them some funds, to transfer the GLMs that you've committed to. So this is what the payment API is for. You can you can perform this, as well as you can use it to withdraw your funds, for example. If you are a provider and you're earning some tokens on the network, you can use it to top up your wallet and so on. So this is like everything that the payment API is going to handle. Okay, cool. So now that we have a rough idea of these three APIs, how can you learn some more about them? I mentioned that we've kind of chosen this REST API approach for the tooling that's around it, and now this is going to be a good example of this tooling. I'm going to switch over to my browser now. And in here, I have the collection of links that I've mentioned before, which you can open. And there is the Open API spec for Yagna. There's this link. So let's go and open it. So all of this, all of the APIs that I've just shown you, they are described using a specification called Open API. And this Open API is, it's a standard. It's a language agnostic sort of standard for defining REST APIs. And the way it works is that you use a YAML file to describe your endpoints and your data classes and so on. So in the case of Golem, there is this repo on GitHub called ya-client. And this repo contains a directory called specs. And in this directory, you have the specifications for all three APIs that I've just described, as well as some common elements between them. And so yeah, let's take a look at what a file like this looks like. So it's pretty lengthy. It's a YAML file, but it's not really that great for readability if you haven't encountered this before. So we can use another tool that was created specifically for this, called the Open API editor, or Swagger editor. I think that's the previous name that they used. It's also included in this link collection that I gave you. So it's here. So editor Swagger.io. Let's open it now. And in this editor, you have a more like a rendered, readable kind of representation of this YAML file. So in this case, we are looking at the market API. If you want to view a different one, all you need to do is you just paste in the file here on the left. So I can switch over to the specs, and I can, for example, take the activity YAML and I view it as raw. And from here, I could copy the whole file and just put it in here and replace it. And this is going to be done dynamically for me. So if I paste it in, we have activity API now. And yeah, so I think this is the best way for you if you want to kind of explore what's possible. Each of these for each of these endpoints, there is documentation, and we also have the possible error codes included, and also the schemas. So these are the all the requests and other objects that are used throughout the API. So you can take a look at the types behind them and so on. So yeah, so if you want to explore the Yagna API, I think this is the best way. Cool. Let me jump back to. Okay, sorry. No, actually, one more thing. So with this in mind, there is actually another reason for which we picked this Open API, and this is because there are actually tools which let you generate clients for your APIs in a variety of different programming languages. So essentially, this means that if you have an API that's described using this standard, there is very little effort required from you to get a working client to make requests to it. And this is actually included here as well on this list. We currently have like 2 officially supported API clients. One for Python, and the other one is for JavaScript / TypeScript. So you can include this one in your project and just use it straight away to make REST API calls to a Yagna node. But with all of this said, using the API directly is kind of low level in the sense that it still requires you to add a lot of boilerplate and have some context on the actual kind of API. So to make this easier for you, we've implemented like high level SDKs, high level APIs. For again, the 2 official ones are for Python and for JavaScript, and they are linked up here. And these APIs are the ones that we'll be using in the examples that I will show you in a second. So they should be able to handle most use cases, and they will be easier for you to use. And if for some reason you would be you would need to make some lower level calls, they include the clients that I've just mentioned previously, so you can use them there as well. Cool. I'm going to jump back to my presentation now. So yeah, we're kind of still on this API slide, and yeah, so I've started kind of talking about those APIs and SDKs. Here is a diagram which can be a bit overwhelming at first, but it shows you where these fit within the broader scope. So we have on the left we have the kind of the whole requester part. On the right there is the provider, and the requester has this element called the requester agent, which is the logic that will be controlling the daemon. So the daemon has the REST API, and the agent is making the calls to it to achieve some task. And so this agent is actually going to include one of these packages to run your code. So to run some code that you've prepared for your specific use case. And this the provider side of counterpart is going to be the container code, the image that you've prepared for your application. Okay, so I think it's high time that we move on to something a bit more practical. So I'm going to from this perspective, I'm going to switch over to showing you how you can start using those high-level APIs and how you can test your application. And yeah, basically let's get going then. So yeah, creating a Golem app. There we go. So here are a couple of points, but I think that these points are actually sort of the same as one of the tutorials. So let me just switch over to my browser here, and yeah, and in the browser there is this one. There is the development tutorial under this creating a Golem app section, and this tutorial is taken from our handbook. So there is handbook.golem.network. Let me open it now. Cool. So a quick digression here. If you're new to this handbook, this is like I think the best resource to start kind of learning about how to integrate with Golem. There is tons of various materials. One of the sections are requester tutorials right here, and the one I'm looking at is called Hello World from Golem, and this one is a comprehensive step-by-step guide on how to create like kind of each of the sections to get like a working app, basically. So now let me walk you through what needs to happen to create this application. So first of all, in this tutorial, we start with what we call the worker code. And the worker code is the stuff that will be running on the provider side of things in a container, for example. And it's going to be responsible for executing a chunk of your task. So you need to define this. And I think the most kind of I'm kind of abstracting. I'm not really focusing on the specific example here. The specific example is trying to break some hash by comparing it with with a list of words. So each chunk is some section of this dictionary. But yeah, I'm not really going to go into how we do that. The important part for the worker, for example, is how it communicates with the requester, and this is done through files. So the container is going to have a bunch of files kind of mounted to it from the provider host, and this is where we're going to be putting input files, and also where the requester is going to expect some outputs to show up. So yeah, so out of all this kind of Python code, I think the most interesting part for us right now are these 3 lines, so that we have some paths inside this container, which are sort of well known, the paths into which the requester is going to be transferring stuff in and out of. So sort of we can also, I think I do have a good slide for it. Let me just let me see. Yeah, this one. On the right there is the provider, which is running some container, and this container has a bunch of volumes, and these volumes are those input and output directories, for example, and those are mapped to the actual provider's file system, and they allow us to exchange stuff between the requester code and the provider, the requester machine and the provider machine, basically. Okay, back to the tutorial now. So the next step in this case is how you actually define what's running inside this provider. And in this case, and in most cases right now, this is going to be a Docker container. So we define a Docker image using a Docker file. If you're not really familiar with this, don't worry. This again, it all kind of boils down to these 2 lines. So the first one is defining 2 volumes that I've just mentioned. So these are the directories that are going to be mounted within this container and used for for getting input and creating some output. And then the second one is actually copying the worker script into some another well-known location, within this image, which is then kind of pointed to in the last line. And this is all we need to do basically in our case. Having some worker script that we've prepared, we create this very basic image with 2 volumes and 1 script, and that's all. Like for the sake of completeness, Golem is not going to be running Docker directly. This image is going to get converted into a different format, and this process is described here in the tutorial. But I'm not going to be describing it. It's a technical detail. The important part is that this is a good description of the image itself. Right. The third part is the requester kind of agent itself, and this one is the most open part, because this is where your application-specific stuff is going to dominate basically. The only things that are going to most likely be common between these is going to be how you split your data into chunks. So kind of your definition of a single task for a single provider. So that's one. And the other thing that you should fill in sort of are the steps. So the steps are the kind of the recipe for what needs to happen for each of the providers to get the task finished. So these will include like the file transfers, running specific scripts, perhaps doing some logic on the requester side, and so on. So this is the second part. And yeah, in this tutorial it takes you through how you fill in these gaps. And finally, there is the daemon itself in this case, but this actually takes us to running it on the Yagna network, on how we actually test our application. Right. So let me take this example now. So this hello world example, and try running it on the Golem network first, and then I'm going to show you how you can do it, how you can test it locally using another tool that we've developed. Okay, I'm going to follow the steps from this tutorial. So this tutorial sends us to a section called Request a Quick Primer. So let me open it up. And this section is also part of the requester tutorials, actually the first one. And it takes you through installing Yagna. So we don't really care about Python and Git right now. We're kind of interested in running the Yagna daemon here. So yeah, let me show you how this works, and it's pretty simple, especially for Unix systems. Installing it is just running this single bash script. So where is my tutorial? Sorry, the terminal. Cool. Here it is. It should be large enough for you, but if it's not readable, please let me know. Okay, so I've pasted in this curl, and I'm putting it through bash, and this should install the latest version of Golem, of Yagna on my machine. And it's asking me for the password, so we put in. Okay, so it's done. I think I already had it installed, but just to verify, we can do Yagna -- version, and yeah, this should match basically. So we have the same as the installer was referring to. And yeah, I mean, that's for installing the Yagna daemon itself. That's it. the only kind of distinction is here in the link. So you can either download the bits which are required for a requester node, or you could actually put in as provider here, and that would include some additional packages. But for us, the requester kind of package is enough. It's fine. Now, how do we run it? And this should also be covered here in this tutorial. We've confirmed the versions. We don't really care about deleting the working directories because we're going to be using the test network anyways. Cool. So now run the daemon. Here's the command. We put it in. Okay, there's a bunch of logs, which means something is happening at least. One thing that we can kind of verify at this point is which network we are running, and there is this log line about initializing a payments account. It's this one, and it's telling us that we're using a specific payment driver, and that we're using the Rinkeby Ethereum network, which is a test network. So that's what we needed for this example. And finally, the token is TGLM, which means the test GLM, not the real thing. So cool. We can use it to verify our application, to test it like in a development environment. Okay. Since we want to become a requester, there is an additional thing that we need to run at this point. Here in this tutorial, it's also telling you about generating an app key, and this is a one-time thing. In my case, I think I already have one. But let me just verify this. I'm going to keep this terminal open and just create a new one. Or maybe actually let's do it like this. Okay. And I can verify this by saying Yagna app key list. Okay, so I already have I have a key, and we'll see why this is useful in just a moment. And okay, we already have some tokens on this machine. I can try and verify this as well. So the payment status is here. So yeah, we have some test GLMs. That's fine. And the final thing is enabling our daemon as a requester. This is by default the payment account is not initialized to make transfer, to send tokens to someone else, basically. So we want to enable this. So let's just copy this instruction and put it here. And we should see another log line along these lines, initialize payment accounts. But this time the mode is different. So the mode is sent. This was receive previously. Cool. So we're ready to request some tasks. Since we have the daemon running, and I mentioned that we will use the example that I've just shown you, let me just clone that repo really quickly. So it's probably somewhere here in the dependencies. Yeah. So here is the git clone instruction. There we go. I'm going to open up another terminal and just clone this this hashcracker example to wherever we are right now. Cool. Now let me just switch over to that directory and let's verify what we have. So yeah, so we have the worker script. we have the requester script. So this is the one that we will be interested in a moment. Just to finish up, there is some project specific things that we need to do, and we need to install the requirements. So let me just do some Python stuff for a moment. I'm going to create a virtual environment for it and run this installation so that we have everything that we need. As you can see, it's actually installing the API for Yagna right here. It's one of the dependencies. Okay, cool. Everything went fine. So now let's run this requester application with our Yagna node. And to do this, well, we could do like just requester py, but we're going to get an error at this point. And this error is telling us that we are missing this environment variable, Yagna app key. Remember when I told you about this application key from Yagna? So this is the thing that we need to connect to our daemon running locally. So let me go ahead and grab it. We had it here. So when we listed all the app keys, it's here, the second column called key. So let me copy that. And let's try rerunning our requester application, but with this environment variable set. Now there's stuff happening. You can see we've received a number of proposals from different providers, and we are sending tasks to them. So in the case of this example, we split a dictionary of words into a number of chunks and sent each of them to a different provider, and we are looking to crack a specific hash. And well, we managed to do so. There is this log about finding the matching word, and after that we get like a summary report. So we get a report of how many agreements we've struck, and who computed what, and the total cost for this task. Right. So that's how you can run this, in general, a Golem application on the network itself. But like, what could go wrong? I mean, there is a couple of problems with this. We just had a successful run, but what if something failed? It's not really easy to get the logs from some provider somewhere that another person is running. So we don't really have access to those logs. Another thing is this is not really a deterministic environment. We are not always running from scratch. There will be different machines picking up our tasks, and so on. So it's not easy to kind of repeat the same setup. And yeah, so to address like these sort of problems, we have created a tool called the Golem test harness. So now I'm again referring to this collection of links that we have. Oh, sorry, this is like not really well formatted, but anyways, here is a section, and here is the link to the repo for it. And you can go through the README to learn some more about the test harness. But in a nutshell, what it does is that it runs a network of Golem nodes locally on your machine. And so it's completely isolated. It's always created from scratch, and you can customize it like however you like. So you can run a different number of providers. You can do all sorts of things with it. And the best part about it is that you have extensive logging. So you have logs from all the providers. You have HTTP traffic logged as well. So there's a bunch of different things that will make your life easier when debugging some problems. And how do we use it? How do we run it? The same example, but using the test harness. Let me clone the rep here again. So switching over to my terminal now, and I'll open up another window and clone the repo. Sorry, git clone this. Yep, there we go. And let's switch over to that directory. Now, you can refer to the README to learn how to run it, but Goth is using a tool called Poetry for Python. And so Poetry will handle a lot of the virtual environment stuff for you. So all we need to do is we need to call Poetry install, and this will get all of our dependencies for this project. So it should get us set up for using it. And once we have it installed, we can use one of the commands that we've prepared for you to start this kind of interactive network. So let me do it now. So we say poetry run and po interactive. Again, you will see this in the README. So now we're getting a bunch of logs about the network being brought up. You can see the specific Golem version that's being used, as well as what the network kind of consists of. I mean, what nodes you have. But in a moment, we should see a log pointing us to the Yagna app key that we should be using in order to kind of connect to the requester inside this network. Because like I said, it's fully isolated. It's local on your machine. So you need to know how to reach it. And yeah, in the meanwhile, I'm going to leave 3 minutes at the end of the session for any last minute questions, sort of. Cool. There you go. So there is you get a prompt telling you what kind of environment variables you need to set in order for your application to run. So what we can do is we can copy all of this, because these end variables, they're actually the API, the Python API that we've created is expecting these, so you don't have to include it in your code. And let me get back to our hash cracking example. I've pasted in all of this stuff, and I'm going to try running the requester script again. And right, we're getting some error here while finding a module. So this is probably not a good sign. I won't be debugging this right now, but this is probably because we kind of assume that this is running a different example. So I'm probably missing something. Maybe I don't have Goth as a package itself installed. I'm not sure what's happening here. But yeah, let me not go into this right now. One last thing that I wanted to show you before we finish. There is, again, here at the end, there is a section called VM image debugging. And this one is showing you, there's actually again a tutorial in the handbook for it. And this describes how you can debug your application image before actually actually sending it to the network. And why would you like to do this? Well, as you're developing an application, this image of yours would need to be kind of sent to the providers every single time you want to test it. And once again, there is a problem of not enough information. So you might not have the logs from those providers to easily tell what went wrong. And so we've created a tool like specifically for handling this kind of a situation, in which you can, once you have a Golem image built from a Docker file, you can run this image locally on your machine, and it gives you a terminal. It gives you an interactive shell that's running inside this kind of virtual machine. So you can do all sorts of, you can do pretty much anything you need inside that VM. So again, this will speed up your your development, because you will not have to do as many iterations as you would without this kind of tool. So again, if you're developing a Golem app, or if you're looking to create one, definitely something to consider. Okay, cool. Right. Let me mention something about the bounties that we have as well before I finish. So coming back to this collection of links, there should be. Sorry, let me just refresh it. Yeah, there is there is Gitcoin bounty here at the bottom. So this is the Golem bounty that you can participate in to create an app which is kind of focused on open internet, and that's pretty much what Golem is all about. So yeah, definitely take a look. If you want to do some further reading, we have a collection called Awesome Golem on GitHub. It's a collection of various resources and projects that were created with the platform. So you can take a look to get some inspirations, maybe see what has already been done or kind of attempted. And if you want to learn some more about the new Golem, there is a series of blog posts that you can read. Right, yeah, and as I can see in the live chat, there are also links to the Discord servers. So there is a Discord server specifically for this event, so for the hackathon itself. And we also have a Golem Discord, which is very much active. And if you're looking for help, if you're looking for support, we have people out there most of the time just searching, scanning for any sort of problems that developers might encounter. So again, definitely worth checking out. Okay, cool. Thank you very much for listening. Yeah. Hey, Antek. I think you're muted. Sorry. I thought that was something with my audio, but I think you're muted. Yeah.
Okay, that should be better.
Yeah.
Yeah, Jakub, thank you very much for your presentation. Next up, we have Austin. We're going to take just a very short break, and we'll have a workshop with Austin. So, Jakub, thanks again.
Thank you.
And see you on Discord.
See ya.